Far beyond the stars visible in Earth's night sky, a distant planet has quietly captured the attention of astronomers around the world. More than 120 light-years away, in the constellation Leo, faint infrared light traveled across space for over a century before finally reaching the mirrors of the James Webb Space Telescope. At first, those signals appeared to be nothing more than another collection of measurements, one tiny data set among countless observations gathered from the cosmos. But hidden within that ancient starlight was an atmospheric fingerprint unlike anything scientists had expected to see. The discovery centered on a planet called K218b*, a world already known to orbit within the habitable zone of a cool red dwarf star. When Webb analyzed the planet's atmosphere, researchers found evidence of water vapor, carbon dioxide, and methane, molecules that immediately made the planet one of the most intriguing worlds ever studied beyond our solar system. Then came an even more surprising possibility. Scientists reported a tentative signal that could indicate the presence of dimethyl sulfide or DMS. On Earth, this molecule is produced primarily by living organisms in the oceans. Detecting it on another planet would be remarkable, but astronomers remain cautious. The signal is still being studied, and additional observations are needed before anyone can claim it has truly been confirmed. Even so, the possibility alone has transformed K218b into one of the most closely watched planets in modern astronomy. The discovery came from one of Webb's greatest strengths, its ability to study distant atmospheres using infrared spectroscopy. As K218b passed in front of its parent star, a tiny fraction of the starlight filtered through the planet's atmosphere before continuing toward Earth. Different gases absorb different wavelengths of light. By carefully measuring which colors disappeared from the spectrum, scientists were able to reconstruct the chemical composition of the atmosphere without ever seeing the planet directly. It's an extraordinary achievement. Rather than photographing alien landscapes, Webb is effectively reading the chemistry of worlds located hundreds of trillions of kilometers away. The first atmospheric ingredients matched earlier expectations. Water vapor suggested the presence of hydrogen and oxygen-bearing compounds. Carbon dioxide pointed toward an active carbon cycle, while methane hinted that complex chemistry was taking place high above the planet. Together, these molecules painted the picture of a world unlike any planet in our own solar system. K218b is classified as a super-Earth a planet significantly larger and more massive than Earth but much smaller than the giant gas planets like Neptune. It circles a small red dwarf star roughly every 33 days, receiving enough energy that temperatures could allow liquid water to exist under the right conditions. For years, astronomers assumed that Earth-sized rocky planets were the best places to search for life. K218b challenged that assumption almost overnight. Instead of having a thin nitrogen-oxygen atmosphere like Earth's, this planet appears to possess a thick envelope rich in hydrogen. At first glance, that might seem like bad news for habitability. Yet recent research suggests that hydrogen-rich atmospheres may actually help maintain stable temperatures across some worlds, depending on the planet's structure and composition. Some scientists have proposed that K218b could belong to a new category known as a Hycean world a planet covered by vast oceans beneath a hydrogen-rich atmosphere. If such planets truly exist, they could dramatically expand the number of places where life might be possible. That idea remains under active investigation, but it has already sparked a major shift in how researchers think about habitable environments. Instead of searching only for planets that closely resemble Earth, astronomers are beginning to consider that life could emerge under a much wider range of conditions than previously imagined. If K218b ultimately proves to host a stable ocean beneath its atmosphere, it would represent one of the most promising environments ever discovered outside our solar system. And if future observations confirm additional biosignature gases, the implications would extend far beyond a single planet. For the first time in history, humanity may be approaching the point where the atmospheres of distant worlds can reveal whether biology exists beyond Earth. Not through science fiction or speculation, but through measurable evidence carried across space by light itself. The story of K218b is still unfolding. Every new observation from the James Webb Space Telescope adds another piece to the puzzle, bringing us closer to answering one of humanity's oldest questions. Are we alone in the universe? Right now, no one can honestly say that question has been answered. But for the first time, scientists possess a telescope powerful enough to begin searching for the answer with unprecedented precision.